Hello, everybody. It's Mrs. Pound, and I'm here with another section on weather from Chapter 5.2. So today's topic is Section 527 on air masses and fronts. So our objectives today are to classify air masses, explain how fronts are formed, and evaluate a front to determine what weather will result. So let's talk about air masses. What is an air mass? An air mass is a large body of air with consistent temperature and humidity. So the two things we're going to look at are basically how warm and cold it are and how humid it is. Now, there are a number of kinds of air masses, and the first I want to talk about is maritime polar. Now, they tend to take on the characteristics of where they form. So maritime polar air masses form in polar regions over the ocean, over water. And so that makes them cold because they're polar and humid because they form over water. Hence, maritime polar, okay? And the symbol on a map will be a little m and a large P. So maritime, humid, polar, cold. Another type of air mass is maritime tropical. Now, this maritime means it's humid, tropical means it's actually warm, and these tend to form over tropical areas in the oceans. There are also continental polar air masses. Okay, so continental actually means it's dry because land is dry, and polar means it's cold. Okay, so continental polar is cold and dry. There's also continental tropical. These, continental being dry, tropical being warm, these are forming over continental areas and tropical regions. And I have a desert here because, like in northern Africa, that's where these would form, would be over the desert. And then we have Arctic air masses. These are extremely cold. These form um, we get Arctic air in the winter from the poles, just extremely cold weather. Now, as these land masses move, if they stall out in an area for a long time, they will start to take on the characteristics then of the area where they have stopped and stalled out. So, an air mass, an air mass can start out as Arctic, but then it can start to take on the characteristics of other air masses if it's in a different area for long periods of time. Okay, now air masses are involved when we have fronts. A front is the boundary between two air masses, and it's at these fronts where we tend to have our most extreme weather or where we have weather changes. So these are formed when two air masses encounter each other. The type of front is determined by the way the colder air mass is moving. And it's usually responsible for weather changes. So when we have a change in weather, it's probably because we have had a front and we have had a change in air masses that are over our area. So if it's been cold and then it becomes warmer, it's because we have a warmer air mass moving into our area, a more tropical air mass. If it then becomes cooler, we're probably getting some polar air. Or if it all of a sudden gets really wet and humid, we have air that's from off the ocean somewhere. So let's first talk about a cold front. This forms when a cold air mass overtakes a warm air mass. Dense cold air lifts the warm air, and it forms cumulus and cumulonimbus clouds. These are what cold fronts are what produce heavy thunderstorms along what's usually called a squall line. Now, at the end, we're going to review and I'm going to show you a picture of what the air masses look like when they come together. There are also what we call occluded fronts. This forms when a fast moving cold air overtakes a warm air mass that is moving in the same direction and lifts it entirely off the ground. Okay, instead of pushing it like in a cold front and coming up behind it, it actually lifts it off the ground. The advancing cold front joins with the cool air mass already beneath the warm air mass and produces low temperatures, many clouds, and lots of precipitation. We also have warm fronts. This forms when a warm air mass overtakes a cold air mass. The less dense warm air rises above the cold air and forms a gradual slope, often marked by clouds. And warm, humid air can produce nimbostratus clouds, causing heavy rain or snowfall over large areas. Okay, and the last type of front is a stationary front. This is where two air masses meet and stall with neither replacing the other. This produces weather similar to a warm front. So I know this picture is a little bit fuzzy, but this summarizes those different fronts. Here we have a cold front. This is our cumulonimbus cloud. Notice compare the cold front compared to the warm front. The cold front is really acting like a plow in a way. It's plowing right through there. Notice not so much of a gradual lift up as the warm front. And so cold fronts, when a cold front comes through, it's usually really fast. All of a sudden it's nice, and then all of a sudden there's stormy weather. That's because a cold front is not gradual. It happens really fast because this slope is not gradual. It acts like a snowplow, really, in a way, and just changes the weather very quickly. Warm fronts, on the other hand, are very gradual. And so, with that warm front, you can see this gradual cloud change. You'll start out with some cirrus clouds, and they'll gradually change and become a cloudier and cloudier and cloudier until we have some nimbostratus clouds. So, much more gradual. Not such a drastic temperature change. You know, when a cold front comes through, we can go from very warm, like 80 degrees, down to, say, 60, 70 degrees, like that. Okay. Warm fronts are more gradual. There's a gradual warming of the air. Here's that occluded front, and see how this cold front is actually going under this warm area, and there's another cold front in front of it, cold air mass. And so this warm air mass is lifted right up by these two cold air masses. And so that's an occluded front, and you're going to have stormy weather with that. And then there's the stationary front. These guys are not moving, but there's some air up here causing some stratonimbus clouds that are producing rain. That's because the air masses aren't moving, it's there for a while. Okay, you're going to have some long rainy days from a stationary front. So, what I want you to do is, I want you to, by your name, tell me what kind of front is your favorite. Okay. Tell me what kind of front is your favorite and why. Maybe you like a cold front because you like a really good thunder and lightning storm. Maybe you like the warm front because you really want like warm, steamy weather. So tell me what kind of front you like and why. So our objectives today for today's video were to classify air masses, explain how fronts are formed, and evaluate a front to determine what weather result will result. Excuse me. I'm really trying to rush here today, aren't I? So 5 questions, and I'll be back with more about weather. Like I said, this is a pretty long chapter, but an important one.